Okay, I hope we haven't overrun too much this afternoon. We're going to try and keep this succinct, pithy, to the point, laser point making by my 5 FiReStarters will now commence in the excellent company. Why don't you go first, Ray?
Okay, great.
I'm Ray Rothrock. Go on.
Ray Rothrock, CEO of RedSeal. We're a fast-growing, cool company. What do? This is a new era of cyber. I've been investing in cyber for 30 years, and I think we're in a new era. You have been hacked. All your prevention and all your detection, good luck. It's necessary, but it's not sufficient. You are under attack. If you're under attack, what do you do about it? It's like this building. If this building caught on fire, the sprinklers will go, the fire department will be called. That's what we do. We tell you how your network is built, what's operating, what's connected, what policy, what audit, all that stuff. We connect it all, whether it's a prem network, a cloud network, or whatever. We have 237 companies that use it. And let me just give you an example. Equifax. Very large company, half their market value is gone. I'm sure they were doing good things. Our software would have detected the problem that was not done by this engineer. He did not upgrade something. We test everything in your network. We don't prevent, but we give you intelligence that you cannot get other places. WannaCry and those things, if you were running RedSeal, you could instantly know whether or not you had the problem. We had one customer with 5 million endpoints, 10,000 WannaCry incidents, 110 of them mattered. We told them which 110 to fix. That's the kind of stuff we do. So we model and risk score your network. Measurement is everything. Boards love measurement. I love measurement.
Did he pay? Did he pay the WannaCry guy? Was he forced to pay out?
No, he didn't pay. But okay. Should have.
That's the kind of secret we need to have.
That was laser focused.
Yeah, you did that beautifully. In fact, you did it in a minute under time, so that's excellent. That's the kind of. He set the bar for you guys now.
Okay.
So
I was hoping to use his extra minute.
Go right ahead.
Well, you can try, Trevor, but I'm not sure I'll allow you. Go on. This is Trevor Rudderham, President and CEO, Haydale Technologies. Haydale were here last year. You may have met them then.
And the year before, and I'm going to mention that actually. Yeah, Haydale Technologies, Inc. is the US arm of Haydale, which may be familiar to some, if not all of you. They were a FiReStarter 2 years ago in recognition of their world-leading capability in the area of functionalization and application of graphene. 1 year ago, in fact, tomorrow to be precise, so it's an anniversary tomorrow, they acquired a US company which is now called Haydale Technologies, Inc., which was going to be the springboard, and is the springboard for the graphene capability, but also had some people, some manufacturing assets, and a material which we thought would be highly synergistic with what we're doing in the graphene space. That material is silicon carbide. Silicon carbide is very, very old. You've heard of it as carborundum. It's used in grinding and polishing. At the other end of the spectrum, it's made into continuous fiber, which is used in aerospace and military applications and is hugely expensive. Where we fit in is in between the two. We make microfibers and fibers. The microfiber is the smallest. It's about 1/100th the diameter of a human hair, and it's about 10 times as long as it is in diameter. The process for making it, coincidentally, was actually invented at the University of Utah 40 years ago. So what is a company with a 40-year-old material technology doing as a FiReStarter? Good question. 2 things came to bear. First, and we've talked a lot about this at FiRe, there's a need to make more from less. We've got reduced energy, we've got less space in the world, we're depleting our natural resources. We call it functional intensity, getting more function out of cost, more function out of volume, more function out of weight. Silicon carbide can do that. The problem is it's expensive. It checks 2 of those boxes, function per weight, function per volume, but doesn't check the value equation. And that's the other reason why we're here, because something has happened recently that's made us a breakthrough, or made a breakthrough for us. Additive manufacturing, as I think we all know, has the ability to selectively deploy materials in the manufacture of a part where it's needed and not necessarily carry the cost burden of a high-tech material throughout the whole part. Suddenly, silicon carbide, whisker, and microfiber has an application through additive manufacturing which is truly going to drive functional intensity. So we've taken something old, silicon carbide, matched it with something new, additive manufacturing, and make things better.
How is silicon carbide different from graphene in terms of its applications? Sorry, simple, it's probably a bit too big a question.
Well, many different applications for graphene. The extraction of graphene is very different from how we make silicon carbide. Silicon carbide really is about strength. it's making materials much, much stronger. It has other capabilities too. Graphene has capabilities in electrical conductivity, in thermal properties. It also adds strength, but in different matrices. We're very good in, or I say we, silicon carbide is very, very good in metals. It's very good in ceramics. It's not bad in polymers. Graphene is very effective in polymers, not particularly effective in metals, and I don't think we've tried it in ceramics yet.
Okay, we will come back more on that in a minute. Anu, Vaid, tell us about ParentSquare.
Yeah, hi, my name is Anupama Vaid, and I'm the president and founder of ParentSquare. So at ParentSquare, we believe that strong school-home partnerships are important for student success, and in today's age, technology can help build those partnerships and the trust between school and parents, regardless of language, culture, or socioeconomic barriers. So looking at the history of education, the public school system as we know it today came about as a result of the Industrial Revolution in the 19th century. So the intent was to create factory workers and teaching to conformity. So kids were shuttled to school, they were given the education and subjected to tests without any regard to what their interests or capabilities were. So however, today, times are changing. More and more educators are realizing the importance of personalized education. Just like other industries, it's times of revolution. There's one-to-one iPads in classrooms. Educators are talking about project-based learning to capture the interest of the students, also about adaptive learning technologies. In all these talks about how to impart the education and what to teach, what we also need is a change in where the learning happens. So learning is just like work. It's not a place where you go to, it's what you do. Learning can happen in and out of the schools, and it needs to happen beyond the school all throughout the life. And that's what educators realize and need to realize the importance of. So that's where ParentSquare comes in. Even if you look at the facts, only about 14% of the day is what is spent at school by students in a year. So as much as 50% of the test variance is explained by home-related factors. Only about 20% is explained by school factors. So taking all that into account, educators need to learn the importance of bringing parents into the fold as it can move the needle, especially for our underprivileged families. So what ParentSquare does for the families is it helps the educators extend learning at home. Educators are busy. There's not enough time in the day for them to realize and get parents involved. So ParentSquare makes it incredibly easy for them to share the information, and when they share information, in turn for parents to share that information with the students, and reaching the parents where they are in terms of email, text, voice, app notifications, in the language that parents understand, and at the time they're ready for that information. So taking all that into account, as they reach the kids, it's, it teaches the kids that to learn how to learn, which is the most important 21st century skill that we need to teach.
Great, thank you. We'll pick up on more of that in a second. Hank.
My name is Hank Wu. This is my first time at FiRe, so thank you for having me. It's been an incredible experience. Thank you to Mark and the Anderson family. It's just really impressive, the people in the program. I'm the chairman of this company called TruTag Technologies, which means I really don't know what's going on here. I'm a surgeon by training, and this company was conceived initially to solve a singular problem, and that was the problem of counterfeiting, which we believe to be the biggest business in the world. It's $1 trillion in size, impacts a lot of lives, a lot of jobs everywhere, but there are certain life mission critical things such as food and drugs where you don't want to take a chance on taking something that was not genuine. So we gathered a group of technologists. Our CTO was sold an optical data storage company to Other Logic, and our chief scientific officer came from Illumina. So we invented an optical memory device. It's an optical memory device that's the size of a piece of dust, so it's not really visible. And within that little piece of dust particle, we can embed millions of combinations of optical signature. And this dust particle, among other things, is one, ingestible. It's edible. It's made from a known food excipient, so no regulatory hurdles. It can be placed on pills, on food, and we can embed hundreds and millions of combinations of optical signature within a speck of the dust. So that's part A of the technology. Part B, we created an optical reader, a mobile handheld optical reader that within a second or two can basically process 400 colors, 2.3 megapixels of information. So it can capture and process 100 times more color than any of the existing cameras in the marketplace. So the idea initially was really we can use this to basically put on a pill or food. Before you ingest it, you can authenticate it. It will tell you where it's made, who made it, when it expires, the distribution chain, the network. In fact, we could put a 40, 50-page drug safety and package insert into it in 20 different languages if we wanted to. So that was the whole idea initially, and then we evolved from there.
Yeah, you went on from that. Counterfeit drugs, obviously, people will know, huge global problem, and perhaps not so much in the rich world as in many parts of the poor and the developing world, right? But so with this kit, you can spot, you have the drugs, all the individual pills presumably can all be marked, and then at the end of it, you can identify each pill to prove that it is what it's purporting to be. However, as you say, you discovered a second application for this technology, almost by accident.
It was sort of a gift. So two things. Because this reader initially was developed purely to be able to decipher the massive combination of spectral signature generated by our memory chip, it has the capability to decipher and capture and process enormous amount of color. Well, it turns out that most humans, right, for all of us, we typically have between 2 to 4 photoreceptors, which means we can see between roughly 20 to maybe 40 colors. But this camera has the ability to decipher and process and capture 400 colors, which means it can capture far more information from the world and the environment than we're able to today. And guess what? If you have all that information, then with AI, you have the ability to process it. This morning's talk on image computer processing was enormously interesting. So we found that the camera in and of itself has tremendous applications outside of our sort of our anti-counterfeiting and product identity play.
Specifically, you could identify tumors, for example. I mean, you were telling me, and
imaging tissue.
Imaging tissue.
Colonoscopy, cancerous tissue, skin lesions, agriculture management, for example, because we can look at a plant, a seed, a fruit, and because of the ability to capture color, we can actually differentiate its health, its nutrients, its process maturation, and so forth.
Wow, that sounds like a lot of applications. Let's move on. We're going to, because we can come back to all of these, as mentioned. Shane of Link 3D. This is, well, I mean, we've already been talking about 3D printing, haven't we? So tell us about tell us about this interface, effectively, you're offering between companies and manufacturer and this new manufacturing technology.
Yep, so my name is Shane Fox. I'm the co-founder and CEO of Linked. My business partner and best buddy is Vishal. He's the other co-founder, CTO, and he's the real brain of our operation. So I've been involved in the additive manufacturing space for about 9 years. And I used to come to conferences like this, and you would say 3D printing, you would say additive manufacturing, and no one would even know what you're talking about. So who in here knows what 3D printing is? Let's see a hand. Nice. So how many of you realize that you might have flown on a plane, drove in a car, or the person sitting next to you can actually have a 3D printed implant or 3D printed part? Awesome, great. So our software essentially enables that. So we have 2 products. We have one product that's called On Demand, and it's the world's largest digital supply chain. So we're very selective in who we allow into our platform. So these are industrial-grade service bureaus. They typically have anywhere between $25 to $250 million worth of capital equipment or 3D printers. And we're in 34 countries. So what it does is it gives engineers from basically anywhere around the world access to rapid prototyping or small series production. So we actually, we're proud, we host roughly 2,000 machines in our network with real-time access. 60% of those machines are metal, 30% are polymer, and 10% are composites. So that's our on-demand network. And the one thing I will say, a lot of us at our team have a deep IP and security background. So we use specific layers of technology, encryption, and a host of other technologies to protect your intellectual property or your STL or your three-dimensional files and all the metadata. But we actually just released a product that we call Digital Factory. And it's a very interesting product. It's definitely a first of its kind. And what we do is we help engineering companies connect their software to their hardware all on a single platform using automation. So I'm not going to get into all the technicals, but what our tool does is it, one, analyzes files. It'll look at those files, mostly stereolithography. It will detect if there's an error, and it will auto-heal the mesh for printability. So what we're doing there is we're saving these companies time and money in resource planning and build failures and material waste. The second thing we do is we actually route those orders through our algorithms to the specific machine that the part's parameters or the part's metadata meets. And because we're connecting into the hardware, we understand capacity, lead time, on, off, machines failure, machines being calibrated, things like that. So we help not only route the orders to the correct facility or facilities, we also help them with their facility planning as well. The third thing our tool does is it allows for open collaboration between engineers, application engineers, and supply chain. So we have three-dimensional tools that you can actually view the files, collaborate, annotate, and work through, from the methodology standpoint all the way to prototype or production. And the last thing I'll mention, there's a company that we all know, and they're adopting our digital part inventory within our digital factory to reduce a $20 billion a year part inventory down to $10 billion. And they're doing that through digitization. So connecting their digital files to their engineers and to their machines, and all of their facilities or certified vendors across the globe. So you can imagine the rate of obsolescence in an aerospace company or a biomedical company is quite high, right? Something goes wrong, parts are scrapped. Something gets updated, the FAA comes in, parts are scrapped. With industrial grade 3D printing, you can manufacture low series, volume parts, and 95% of the time that you would in traditional manufacturing. So by connecting all of these things, you can truly achieve real-time distributed manufacturing through your supply chain.
You're generally delivering, in practice, you're offering kind of prototype testing for companies, right? They're coming to you going, I don't know if this is going to work, if I can scale this up. Is that in practice what's happening now mostly, or are you actually offering, full industrial solutions to people?
Yeah, no, the industry is there, right? Most of so 92% of all manufacturing companies in the world are thinking or adopting 3D printing into their manufacturing ecosystem. That came from Deloitte. And it's not so much, when I first got in the industry, it was like, how do you do this? How do you design for this? Where are the machines? How do these machines work? It's now, they need automation, they need efficiency, they need a seamless, secure approach to it. So really, they subscribe to our digital factory. It's a SaaS-based product. Start plugging in their machines and all of their information through our APIs, and they start building.
Ty has a question.
Yeah, well, two comments and a question. One, Angela, with the ParentSquare, I'm really excited. I'm a parent of two middle school girls, and we have teachers that are really engaged and some that are not engaged. And we're in a fairly good school district. We're in a great school district, actually. And I think about what this can do as far as changing the dialogue in the homes and changing the dialogues with the teachers. I'm just so encouraged and delighted to see you here. It's not only a great product, but it's great society, contribution to society. I think that's great. On the airline parts, as an example for 3D printing, I could be at the north end of Sweden and break a strut on a plane, and nobody would carry parts, that type of inventory, and yet the plane could probably take off within a day because they could manufacture and certify the part. I think you've fundamentally changed how economies can flow and how business can continue without having tremendous amounts of overhead. So I'm excited about what you've done. And with the TruTag, one quick question. Tell me more about the lifespan of this TruTag, because let's say I eat it. Now, those of you familiar with Larry Smarr and the microbiome and things about they get measured, for example, these tags kind of flow through the system. It could end up in a sample, let's say, and all of a sudden this TruTag shows up and they do the microbiome study, and it's like, oh, you had fish and it was expired yesterday, and then I go to drink a glass of water and there's like 3 tags in it that says, well, that actually was from like 6 years ago, and it's like, what happens to these tags and how do they expire?
So it turns out that the material we use, which is silicon dioxide, is a very commonly used food excipient. It's already found in tens of thousands of drugs and food products today. As an anti-caking agent, as an excipient, so it's extremely prevalent and it's completely inert. So it passes through the system, but so it's actually not a concern in that case.
But it's detectable. Let's say
It's the detectable dust as it travels through the sewage system later.
It's not detectable in vivo. The idea is really to detect it before.
So it's only on the surface, and
only on the surface, right?
And so this dust particle will still travel through the centuries, having this tag on it, but the odds are nobody's going to ever find it.
It's pretty much disintegrated by the time it comes out
Okay.
the other end. But if you really want to look for
No,
it,
I was just wondering, the side effects of
I feel a
technology.
CTO challenge coming on.
Yeah, it can lead to strange things. I'm
Yeah.
just looking for strange side effects that might.
I'll be looking for a blogger site on that. Yeah.
Okay. All right. Thank you very much.
Anu, why isn't Facebook good enough to facilitate communication between teachers and students and their parents?
I'm sorry, can you repeat?
Why isn't Facebook good enough to deliver that kind of communication?
So, Facebook is a great tool. It's just not custom built for schools. So again, what ParentSquare does is that it plays very well with all the systems at school. So we get into a school, we integrate with the system, collect all the data automatically, set up all their groups. And second, it's very private and secure. So you're only getting access to your information. And it has all the built-in dimensions and built-in tools for all the businesses of school, fundraising, volunteering, anything that parents need, check grades, attendance, and all that good stuff.
Ray, a quick question for you before I come to the next question. This is an incredibly crowded marketplace. How do you differentiate yourself from all those other?
All the other,
cyber
and there's
team?
about 2,000 of them,
Yeah.
mostly do protection and detection. That's literally what they do. They look for problems and so forth. We're out of that phase. What we do is we model the network. We actually build a software model from all the configuration devices in your network, the routers, the firewalls, the cloud connections, the VPCs, everything. Nobody does that. Nobody. We calculate every path. We calculate every downstream risk. We import Volscan data, and we can tell you what's being scanned, what's not being scanned. What level of upgrade have you done? Is it secure? Is this right spot?
You prioritize vulnerabilities.
Totally prioritize the vulnerability. Because even a small network may have millions and millions of vulnerabilities. Not all of them are the same. You want to focus on the ones that matter.
Yes, sir.
Hank, what about the use of your systems, your tags? Are they cheap enough so that you could use them for finding contaminants by putting it into the original materials, which later get spread out all over the place, and then you pick them up, so that you could find out what sort of contaminants existed in food that you were eating? I mean, that problem is terrific when you start looking at it, for example, in the oceans.
Right, thank you. So first part of the question in terms of cost. So we actually built a fab. It's the world's most advanced nanopore silicon manufacturing plant. It happens to be in Hawaii, so please come and visit when you have a chance. We wanted to bring the cost of this thing down to a level so it doesn't ever become an issue, basically. So our starting material is a silicon wafer. When you make RFID, you may make maybe 800 to 1,000 per wafer. We could make about 20 million of our chips per wafer. So cost, not an issue. Answer to your second question, yes. The idea really is, the bigger idea here really is supply chain management, right? From cradle to grave, the ability to track and trace from the very beginning to the very end. of a product cycle, which has enormous value for a variety of reasons.
One more question there.
Sure, thanks, Ray. It's Chris DeGiorgio here, thanks. Was thinking about the Equifax breach, and does this one seems a little different. We've had breaches for years, and they've been bad. But they've been, a certain type of breach, but Equifax one seems a little different. What's different about it, and do you think this will force the government to get involved in regulating these a lot more than it has in the past?
Thanks, Chris. Yes, it is a very different deal. As someone said this morning, you could take what's already been breached plus what the Equifax breach, do a correlation on it. We now have profiles on everybody. The OPM, Office of Personnel Management, the United States government, all of that, the 19 million records are out there. All of that now, we now can create these incredible profiles. What's really unfortunate about it, when we do a transaction with Amazon or a bank or whatever, we're volunteering that information. We log in, do the VPN or through the SSL, whatever, and all that's cool. But the Equifax guys collected our data without our permission. So they were selling our data without our permission, and we all accepted that because we wanted to borrow money from banks for cars and houses. But it's different now. That information is really critical. So there's no doubt the government has to step in. A really good friend of mine named Chris, this could be the Enron of breaches because of its scope, because of its short-term nature. The thing that really, I sit on a bunch of boards and a couple of public boards. The thing that really got me about this one was the management team's incentives. They were incented not to do cybersecurity. It's staggering. They recalculated the P&L sheet and were paid out according to, they didn't have to count lawsuits, fines, or any other things that affected their business. And it's just staggering to me that a board or a country and a government would allow such a thing to happen. So there is no doubt in my mind there are going to be there's already been some, but there's going to be some serious stuff, not unlike what happened after the crash with Sarbanes-Oxley.
We're getting into politics, which is where I'm going to leave it. Because we're out of time as well. Guys, thank you very much.
Thank you.
Thank you.